Okay, good afternoon, everyone. I firstly would like to apologize for the delay in today's webinar, and the reason being some technical issues that we had with the system. And a very good day to all of you, whether it's morning, afternoon, or evening. It's currently 15:50 p.m. here in Bonn. My name is Marlon. I work for the Transparency Implementation Support Unit at the Mitigation Data and Analysis Program of the UNFCCC Secretariat, and we provide support to non-Annex 1 parties, including assisting the consultative group of experts in implementing the work program. So let me welcome you to the final webinar organized by the CGE as part of its work program for 2018. Now, this webinar is about using LEAP as a software tool to help you in your decision-making processes with respect to mitigation. The webinar is scheduled for around 40 minutes, and it includes two special guests. One is Mrs. Sandra Mochfanadi from the Department of Environmental Affairs in South Africa, who's also a member of the CGE, and the other is Mr. Charlie Heaps, a senior scientist at the Stockholm Environmental Institute in the US. So before we start, just a few housekeeping items. Please, can you ensure that you mute your mic on the webinar system? And then we will have a Q&A session at the end. And we invite you to send your questions to the Secretariat using the private chat function of the WebEx system. And please do so as the webinar progresses. Then we could take up these questions at the end. So firstly, I would like to invite Sandra to give us an introduction to this webinar and to the work of the CGE. So Sandra, the floor is yours.
Thank you. Yes, as Marlon has already introduced me, my name is Ramos. I work for the National Department of Environmental Affairs in South Africa. I am also a member of the consultative group of experts. I would also like to warmly welcome you to this webinar on using the LEAP tool. The LEAP, known as the Long Range Energy Alternatives Planning System, is a widely used software tool for energy policy analysis as well as climate change mitigation assessment. It is being used by a wide range of organizations as well as many countries worldwide. And as already alluded by Marlon earlier, Mr. Charlie Hibbs will give a detailed presentation on the application as well as the use of the tool. Myself, as a member of the CGE, I'll just give a brief overview on how it can assist the countries as well as share some information on how the training materials as well as the tools for building capacity for the purpose of reporting in biennial update reports and national communications can be accessed within the UNFCCC website. So I will now begin with my presentation. So why are decision-making tools important? The decision-making support tools are essential to grasp the extent as well as the depth of climate change impacts in our societies. They do so by providing validated as well as predictable analytics framework to transform data into meaningful and comparable information that can be used as a critical input to the process of decision making. So tools like the LEAPs are very important and are able to assist countries when it comes to decision making. How can they assist in terms of energy planning for the purposes of making decisions? They can be used as modeling national systems, national energy systems. They can also be used for assessing the greenhouse gas emissions associated with these systems. They can also be used for creating and comparing alternative baselines and mitigation scenarios. They can also be used for assessing the costs and benefits of alternative policies and measures. And this tool, the LEAP, is a very user-friendly and free tool for integrated resource planning and greenhouse gas mitigation assessment. It can be used by a city, the state, national government, regional, and it can also be used on global scale. So this is why this webinar is being conducted, and it will cover the LEAP as a tool that you may find useful in your work. Next slide, please. So as I already said, as the CGE, there has been some training materials that have been developed to assist the countries in terms of building their technical capacities for reporting in BURs and national communications. So in line with these tools, the CGE regularly conducts webinars and workshops, webinars like this one. And then it also collaborates with various partners in order to support countries in improving their technical capacity to take climate action and report on them through national communications and biennial update reports. The aspects such as identifying mitigation scenarios and the policy as well as regulatory decisions of each scenario requires in order to translate them into mitigation actions to achieve emission reduction goals, and these are regularly discussed in CGE workshops. For example, the CGE does workshops on a yearly basis, regional workshops. This year we had a workshop on adaptation. The year before last there was a workshop on assessment of mitigation actions. So these are the types of workshops that are being conducted by the CGE. So what are some of the tools that you can access through the UNFCCC website? The tools and training materials for reporting for non-Annex 1 parties. There's also the e-network. And as mentioned by Marlon earlier, you can also contact the Transparency Implementation Support Unit at that email that's provided there. And so that will be all from me as a CG member. I will now hand over to Mr. Charlie Hibbs to give a detailed presentation of the use of this LEAP tool. Thank you.
Okay. So thank you very much for that introduction, Sandra. And now we hand over to Charlie to provide the main topic for today, and that is the LEAP as a tool. I hand over to you, Charlie. Thank you.
Thank you. I think you're going to need to make me presenter again, Marlon. And I think you need to allow me to share the screen again. Marlon, can you hear me?
Yes, we are going to share your screen.
Thank you.
So Charlie, you have the screen.
Can you see the LEAP screen now? Can you tell me when you can see the screen, please, Marlon? Please tell me if you can see my screen. It should say Leap on it.
Sorry, Charlie, we cannot see your screen as yet.
Okay, I'm not sure that I'm sharing it properly yet then. You might need to help me with that. How do I go about sharing my screen?
So I'm going to
If everyone can hear us, my apologies for not being as familiar with WebEx as we ought to be.
so I'm going to send another invite. Charlie,
Yes, hello.
I'm going to send another the link for you. Please accept my link.
Well, can you, okay. Could you not just tell me how to do it? It might be easier.
Yeah, give me a second. I can.
If you just tell me how to do it, that's quicker than sending a link, I think.
So could you please go back?
Go back to
the main screen.
to my main screen, or I only see two screens at the moment.
Charlie, could you please accept my request? Right now I send a screen sharing program.
Okay, I'm doing it now.
Could you please check your email?
Yeah, I'm doing it now. I'm almost there. Okay, I accepted. You should have control now, Binosh.
Yes, I have the control. So where is the WebEx? Okay, here. Could you please? Okay, here.
I think here's the main screen. I think you just need to show me how to share the screen again.
Here, if you can go to Kickstart, click on Kickstart.
Click on what? So quick start. Okay.
Yeah. So you can share the screen.
Just
right
here. Okay.
Yes, I'm going to disconnect. Okay.
We'll just hold on 1 second, please.
All right, no problem.
I need to share this application, I think.
Okay.
Please tell me when you can see Leap on the screen.
So we can see the leap. Yes.
Okay. We're away. Okay. And I hope everyone can hear me, all the participants can hear me now, is that right? Can you confirm, Marlon, if it's okay to start
So
now?
we can hear you. We can see the presentation. But right now the presentation moved to the other window again.
Yeah, it's okay. I'll put it back.
Thank you.
There we go. All right, I'm going to start then. So thank you, everybody, and thanks for your patience with our teething problems here with WebEx. And thank you to Sandra also for that great introduction. Marlon, if at your end you could mute, I think that would help the audio quality. I can hear a lot of creaking in the background. So what I would like to do now is take about 20 minutes, give you a little bit of an introduction to Leap for those who haven't seen it before. I recognize some names on the participant list, so I know some of you have seen it before, but I'm going to do a bit of a sort of basic introduction to Leap. And then I also want to just take a few minutes at the end to give you a bit of a sort of a peek at some of the features coming in the new version of Leap, which we expect to release in the new year, probably sometime in January, and that has a few quite exciting new features, I think, for people doing national communications and NDCs. Okay, so Sandra's already said a little bit about what LEAP is used for and how it can be used for NDCs. Let me just go over a few of those points. So first of all, what is LEAP? Well, it's a Windows-based tool. It was originally designed for energy planning, but and that was a very long time ago, about 30 years. And over the years, it's become adapted more and more for doing climate change mitigation assessment. And in particular, it's been applied by a lot of countries who are doing national communications. It's been used to help develop NDCs and INDCs. And increasingly, countries are starting to use it for things like low emission development strategies, or LEDs as it's known. It's been very widely applied now, and kind of one of the key advantages of LEAP is how many people are using it. So there's a really large community of practice of people using it. We don't exactly know how many, but we think there's around about 5,000 people actively using it. And the website has as many as 40,000 members in basically every country in the world. So there's a really large and vibrant community of people using it. It's a Windows-based tool. People always get disappointed that there isn't a Mac version. I'm sorry there isn't at the moment, but at the moment it's a Windows-based tool. And it's very much a scenario planning model. So the idea in LEAP is not just to do an inventory of emissions in a particular year, but it's to look forward into the future and see what your emissions might be in the future under various different scenarios. So typically people will develop a baseline scenario that's more or less looking at what will emissions be if policies stay the same into the future. But it also can be used to look at alternative policies. So you can look at things like, what kind of policies might reduce greenhouse gas emissions, or what policies might help further your development goals. It's typically used at the national scale. I would say probably about 80% of the users of LEAP are working at the national scale on topics like energy planning and greenhouse gas mitigation. But it is also increasingly being used at the subnational scale. We have a lot of people using it in South Africa and Southern Africa for city scale planning, and places like China too. And also we've applied it a little bit in the United States for city and state scale mitigation assessments. LEAP is primarily at the moment focused on the energy sector. So when you're doing greenhouse gas mitigation, you need to think about all sectors, energy, as well as land use, forestry, industrial processes, things like that. LEAP's main strength is in the energy sector, but it can also be used for those other sectors. And I'll tell you in a bit about how we have some plans to actually improve some of the non-energy sector modeling. Another really important point about LEAP is that it's not just a model. So some of the tools out there that can be used for greenhouse gas mitigation analysis really are, almost exclusively models. They're all about the algorithms. LEAP does that as well, but it's also really focused on helping you with all the other tasks. So it's got really strong tools for helping you with data management, help you document your analyses. It has built-in word processing tools. And also for helping you visualize your results and helping you engage with stakeholders. So it's not just about the analysis, it's also about the data management and the communication of national communications and NDCs. It covers all greenhouse gases, but it also covers local air pollution and SLCPs, short-lived climate pollutants. So it goes beyond just looking at sort of the global warming potential of gases. If you want to, you can also go further than that and actually go as far as looking at some of the impacts of pollution. And I'll tell you a little bit more about that if I have time later on. You can actually look at impacts in terms of health impacts, so you can actually calculate premature mortality from the air pollution emissions coming out of LEAP. But you can also look at things like sort of crop damages. It's very much in its structure. It very much follows the IPCC inventory guidelines. Kind of LEAP starts where the inventory process ends. You take your inventory, which looks at what have been your emissions in a recent historical year, and then with LEAP you take those and you project them forward to look at how they might change going into the future. Now, you mentioned something about how LEAP was free. I should just want to be clear that LEAP is free for governments, academia, and non-profits in low and lower middle income countries. We do also offer discounted licenses to those kinds of users in upper middle income countries, but it is distributed on the basis of a license, and users in for-profit organizations or users in OECD countries, as well as users in upper middle income countries, do need to purchase a license. But we do provide it free to low and lower middle income countries to target users in those countries. Let me just say a few words about mitigation analysis. I won't dwell on this because I think it's already been covered, but I think it's important to recognize that it's a very difficult topic. It's not an easy exercise, so people shouldn't go into their NDCs thinking it's a simple calculation. Why is it difficult? Well, it considers the future, which is inherently unknowable, right? The future will depend on the choices we make in the coming years. It's also an inherently political exercise. It requires envisioning alternative future development pathways for a country. And it really requires a lot of detailed data. It requires you to think about how technology trends might play out under alternative policy futures. And that requires detailed technology and activity data. And that's particularly difficult in developing countries where much of the kind of the data you need is either unavailable or of low quality. And developing countries face particular challenges in doing mitigation analysis. Typically, they have less data readily available, and typically they have a kind of shortage of the kind of expertise you need to do these kinds of analyses. So that's been a big challenge for many developing countries. And what countries have tended to do over the last 10, 15 years is very often because of the complexity of the task, they've tended to outsource the work to consultants. And this has really created a problem because it hasn't created the kind of learning that needs to happen so that countries can really think about their long-term development pathways and their long-term low-emission development pathways. So that's been a real challenge for developing countries. So LEAP, in a way, has been sort of responding to some of those challenges. So it can help address, in only a small way, but it can help address some of those issues. So how does it help address those issues? Well, firstly, it's designed to be very usable in the kind of situations that people encounter in poorer, smaller developing countries. It has very low initial data requirements, so it makes it usable in situations where maybe you don't have a lot of good data, and maybe you don't have a huge number of people able to work on the task, so you have limited expertise. It's designed to be very user-friendly, and it really emphasizes results communication. And it's really designed not to be used by expert modelers, but it's designed to be used by planners. So it's designed to be used by people who sit in ministries of energy and ministries of environment. So we're really trying to make a model that could be used by someone who's not necessarily an expert modeler. Although expert modelers use it as well, but they're not our first audience. It's a very demand-led program, so it really asks you to think about your broader development goals. So I think it really speaks to the kind of issues that are of interest in many developing countries. It's not just about identifying greenhouse gas mitigation investments. It's about thinking about what kind of development future are you interested in your country. It's also designed to be very fast and interactive. And that makes it very suitable for engaging with stakeholders. You can actually show your results to stakeholders. They can suggest maybe some different perspectives, and it's easy to quickly incorporate them into your modeling and to show the implications back to your stakeholders. Okay, so in a small way, it's designed to help with some of those challenges that developing countries are facing. Let me move on to the structure of LEAP, and I hope I'm not going too fast with the screen changes here. So this green chart here just shows you the rough layout of the kind of how the information flows through the software. So in LEAP, you always start out at the top with some kind of demand analysis. So that's where you think about the consumption of energy in the country. that might be influenced by certain trends in demographics and macroeconomics. So, how fast is your economy growing? How's the population growing? Is the population shifting from urban to rural? Is there any structural shifts going on in the economy? Maybe in many countries, the industrial sector is decreasing in importance and the commercial sector is increasing in importance. So those kinds of trends you can capture. And then you use that to do a demand analysis, which typically or ideally might be reasonably sort of bottom-up oriented. If you're going to think about what your potential is for avoiding greenhouse gases, then you really need to start by thinking about, where are we consuming energy today and how might that change? So the demand analysis will basically lead you to calculate projections of energy consumption in every sector of the economy for every fuel. So you'd look at things like household, industry, transport, agriculture, services, and you'd calculate the fuel consumption in all of those sectors, and you'd project them into the future. The next most important box is this transformation analysis. That's where you look at how do you produce that energy. So how are you going to produce the final consumption that you're consuming up here in your demand analysis? So there you'd think about things like electric generation, oil refining, how you're converting primary fuels into the final fuels that your various sectors consume. You might also think about, issues that are important in particular developing countries. So, for example, charcoal making is really important. Converting wood into charcoal, that has huge energy losses associated with it. So you can capture all of those things under transformation analysis. And then finally, there's a sort of resource analysis. That's where you're saying, based on the consumption of primary fuels that you've calculated in transformation, how does that compare to the availability of fuels? So there you think about, what's the availability of fossil fuels, but also, what might be your potential for different renewable technologies like solar and wind and hydro and geothermal, things like that. So that's basically the energy calculations. That's kind of the main spine of the model. Then in addition to that, you can also do non-energy sector analysis. So there you can think about things like industrial process emissions, solid waste, any of the non-energy related sectors that produce emissions of greenhouse gases. LEAP does also now have a capability to think about land use change and forestry. It does not yet calculate the greenhouse gas sources and sinks associated with that, but that's a feature we will be adding in the very near future. Okay, so those are the main spine is the energy calculations, and then kind of hanging off the side, you have the ability to do cost-benefit analysis. So in each of your scenarios, you can say, what is the cost of the technologies that you're purchasing? And you can compare those costs across different scenarios. So, one scenario, your baseline scenario, for example, might have not very much in the way of energy efficiency. You might do a lot of energy efficiency in your mitigation scenario. That means you will have to buy more of the efficient devices. So you might spend more on, say, efficient refrigerators or efficient lighting or efficient cars. That will cost you some money in your demand analysis. But you will then hopefully save some money because you won't have to generate as much electricity, you won't have to build as many power plants, and you will save on fuel costs as well. So LEAP lets you do all that kind of accounting, and it sums it all up in the integrated cost-benefit analysis, and it will calculate the net present value of one scenario versus another. Okay, that's the cost-benefit analysis. On the other side, you have the environmental loadings. So the other thing you can do in LEAP is wherever a fuel is being combusted, you can specify emission factors. LEAP has built into it the IPCC Tier 1 and Tier 2 emission factors, but you can also add your own emission factors specific to your own country. So it's very easy to sort of match up your analysis of what you've been doing maybe in your inventory analysis. And then LEAP will multiply those emission factors by relevant energy consumption numbers in order to give you estimates of total environmental emissions. It can do greenhouse gases, but it can also do short-lived climate pollutants and local air pollutants as well. So that's the environmental loadings. And then finally, we have this sort of add-on component, which is fairly new in LEAP, called IBC, the Impacts Benefits Calculator. And what that does is it takes the emissions coming out of LEAP, feeds them into a global atmospheric geochemistry model and actually looks at how those emissions disperse around the world, and it uses that information to calculate population-weighted concentrations of secondary pollutants. So in other words, it's calculating the exposure of people to different key pollutants, and then it uses that information in conjunction with a set of exposure response functions that translate the exposure into estimates of impacts. Currently, we calculate two main types of impacts. So one is premature mortality. So we're actually calculating how many additional people are likely to die at a younger age as a result of their exposure to pollutants. But we're also calculating crop losses as well. So we're calculating how many tons of different key crops are likely to be lost because the pollutants cause a reduction in yield of those crops. So that way you can get, you're not just looking at the climate impact, but you're looking at some of the sort of health and ecosystem impact. So you can see some of the sort of co-benefits of taking climate action in different scenarios. It also allows you to calculate temperature change. So you can see what is the global temperature change implied by the emission scenarios that you're calculating. So those are the main calculations in LEAP. As I said, LEAP is very oriented around the idea of scenarios. So it's sort of absolutely sort of fundamental to the design in LEAP that you can tell sort of stories about alternative futures. Let me just say a very quick word about this. So the idea in LEAP is that you can construct lots and lots of different scenarios, and it has this concept of inheritance, where one scenario can inherit the default characteristics of a parent scenario, but then just sort of you just have to say what's the change in one scenario versus another. So that makes it very easy to specify scenarios. You can do very minimal data entry, and it really streamlines the data management process. And you can see kind of an example of that over here on the right. Here we have a baseline scenario, and then we have lots of little sort of small individual policies. It's quite small text, I'm sorry for that. So for example, you might have lots of individual measures like, electric vehicles or improving transit load factors or bus electrification. This is actually an example of an analysis that we did for the state of Massachusetts in the US. So you can see you can have lots of little individual measures. Think of those as being maybe similar to NAMAs, your nationally appropriate mitigation actions. And then you can package them all together into larger integrated scenarios. So here we have a policy called All Policies. You can see the All Policies is a combination of a transport package, a residential package, a commercial package, etc. And the transport package is basically itself a combination of all these individual measures. So it has this idea of letting you try out permutations and combinations of measures and combining them into overall scenarios. So the measures, as I said, are similar to sort of your NAMAs, and then the overall scenarios are maybe similar to your overall NDC analysis or your overall low emission development scenario analysis. So it makes it very easy to try that out. And then down here at the bottom, you can see the result of that. Here we're actually trying out two scenarios. The colored in areas in the chart are your overall integrated all policies scenario. You can see here we're reducing emissions by a lot, and the dotted line above is what you avoided versus your baseline scenario. So the baseline would have kept going up, but because we did all these measures, we managed to reduce our emissions quite considerably there. So that's scenarios in LEAP. Let me just say a few housekeeping things. How do you get LEAP? So if you're interested, write down this web address. So energycommunity.org is the LEAP website. That's a place where you can download LEAP. It's also a way you can get access to lots of LEAP-specific training materials. There's also a very active technical support discussion there. So you can post questions. Please try to search the discussion forum first to see if someone else has already had the same question as you, because quite often you know, if you're facing any problems, you'll find that other people have already had that problem and already solved it. So try to use it as a knowledge base if you run into problems. As I already mentioned, licenses are available at no charge to non-profit, academic and government institutions based in low and lower middle income countries, and then there's discounted licenses for upper middle income countries. Probably most people do need training to use it. We do increasingly see people taking and running with it on their own without any training at all, but in general I think you should plan on getting some training if you're going to use it seriously for an NDC. Training is available through us at SEI, or there's various regional organizations that we know well and we could recommend to you if you want someone closer to home to give you training. And please also check the LEAP website for news of training workshops. We don't have any scheduled at the moment, but very often we do run regional training workshops. We've done a few in conjunction with UNFCCC in recent years, and sometimes they organize regional training workshops. So keep an eye on the website for announcements. Let me just say a few words about some of the features that are coming in 2019, because I know some of you online have been past users of LEAP. So firstly, let me tell you about what's coming in the very near future. Probably, I hope this will be in January. It might be February. And there's a lot of quite exciting features, I think. So the first thing we're doing is we've been improving the impact calculation routines. And now we'll be able to look at health impacts disaggregated by gender. So in the past, we just had sort of total number of deaths, but now you will actually be able to calculate how that's disaggregated both by age and by gender. So you can get really a very interesting new dimension on what are some of the development implications of alternative low emission development strategies. You know, some of them might focus more, for example, on clean cooking, which might have very big benefits, particularly for women who are the primary cooks in many countries. So now you'll be able to calculate those kinds of things within LEAP. And in particular, we've added a new kind of methodology for doing a very good job of looking at indoor air pollution. So we're particularly looking at the impacts of cooking. We've also added the ability to look at yearly global climate impacts. So what are the actual year-on-year temperature changes implied by the emissions from your scenarios? We can't show you the temperature change in your own country, but we can show you what's your contribution to the global temperature change, and that happens across all gases. We've recently added the ability to look at HFCs as well as the more common greenhouse gases. Another very exciting feature is this new modeling tool called NEMO, which stands for Next Energy Modeling System for Optimization. And this is basically, we're revamping the optimization modeling capabilities in LEAP, which in the past have been fairly basic, but we're adding this new super fast optimization modeling engine, which will enable us to look at a bunch of new issues. Probably the most exciting one is it will enable you to look at energy storage. So energy storage is something that LEAP could not do before, but that's really key for looking at large-scale deployment of wind and solar. You know, you need to balance building wind and solar with energy storage so that you can manage the sort of the spikes in supply from the variable renewables. That will be a new capability of LEAP in 2019. We're also working on a new cloud-based technology database. So that will be a database containing cost, emission factors, and technical characteristics of various energy technologies. That will live in the web. You can use it to access much better data for your analyses when you're working with LEAP, but it's also going to be designed as a totally open system with a web-based API, so you could potentially use it to connect to any other modeling tool. Even if you choose not to use LEAP, you could use it if you were working with Markow or one of the other tools out there. And overall, the new version is also going to have big performance improvements, so it's going to be much more responsive and have faster calculations. And then coming a little bit later in 2019, we're also working on a few other things. This will probably be sort of mid to late 2019. we're developing a new version of the air pollution modeling in LEAP that will work at the city scale. So you'll be able to look at impacts disaggregated down to a much finer geographic scale. So you'll be able to say, you know, not just what's the emissions in one country, but what will be the emissions in grid squares within a country. And you'll be able to map the emissions and the concentrations and the impacts onto those grid squares, actually display them on graphical maps within LEAP. So that should be quite useful for people looking at the sort of geographic distribution of impacts. We're also adding much more detailed methods for modeling land use change and forestry, and in particular for looking at greenhouse gas emissions from those sectors. Very much following the standard IPCC forestry sector GHG inventory protocols. And then finally, we're working on, we haven't really got a name for it yet, but we're calling it Web LEAP, which is basically the ability, you'll have the ability to publish the results from your LEAP analysis to a website so that you can make them easily accessible for any of your stakeholders. So, you know, you can, it's as a way of encouraging broader stakeholder engagement on issues like NDCs and LEDs. Okay, how am I doing for time here? I just got one more chart, and then hopefully I've got 5–10 minutes to show you LEAP in action. Before I do that, though, let me just mention two other tools that you might be interested in looking at. So I've talked about LEAP, which is focused on climate mitigation, but SEI does also develop some other tools. So one is WEEP, which is the Water Evaluation Planning System, which is a very powerful software tool for integrated water resource planning. It shares many of the same concepts as LEAP, and you can even connect the two tools together if you want to do energy water nexus analyses. So if you're interested in that, please visit weep21.org. And another tool is a website called WeAdapt, which is a popular online platform with for accessing data and for sharing information about climate adaptation. So that's weadapt.org. So if you're interested in the topics of water and climate adaptation, you know, please check out those two websites as well. What I'd like to do now, Marlon, can you tell me, can I take another 10 minutes? Is that okay? Okay, so what I'm going to do now, if I can get it to work, is I'm going to switch over and actually show you a few of these things in LEAP. I can't give you a detailed training on LEAP. That would take about 4 or 5 days, but let me just give you a hint of the kinds of things it can do. So I'm actually going to pull LEAP up now, and I hope you can see it on screen. Can you see that on screen now?
Yes, we can see it. Great,
okay. So what you're seeing here is the main screen of LEAP. You can see it's a Windows-based application. As much as possible, we try and make it familiar to people who use standard Windows tools. So it has a tree, for example, that's very much like using the File Explorer in Windows. And in general, it's somewhat similar to using Excel and tools like that, but it's more specifically adapted to the needs of doing energy modeling and climate mitigation analysis. So let me just make the font a little bit bigger so it's slightly more readable here. So you can see over here we have different views of the screen, views on an energy system. So this is kind of like the main structure of the model. There's an analysis view. That's the place where you build all your data structures, where you create your scenarios, where you actually put in all the data associated with your country. So typically you will open up a data set for a particular country. Here you can see we've got a data set called Fredonia Exporter. It's just like a sample data set for a fictitious country. That's the analysis view. That's where you sort of do all the creating. The results view is where you look at the results. The energy balance view is a particular view that shows you energy balances for your country, which are calculated as an output from LEAP. Energy balances are kind of a very standard way of showing how energy flows through a country. They're used by ministries of energy, or they're produced by the IEA, for example. If you're doing a greenhouse gas inventory, you've probably had to grapple with an energy balance. And then there's a few other views as well. There's one where you can document your model using the notes view, and there's a few other ones, and I'll show you some of those in a minute. Over here to the right of the views is the actual data structure. So here you can see, for example, we have energy demand broken down by sector. Here we have energy transformation broken down into major sectors like electric generation, charcoal production, oil refining, those kinds of things. So this is where you're converting primary resources, which are entered down here, into the form in which they're consumed up here under energy demands. So kind of the calculation works from the top down to the bottom, but the energy flows from the bottom up to the top. It flows from resources to demands. And this tree structure is really different in every country. So your job in using Leap is to sort of design this tree. But here's like one example. Here we've got demand broken down into households. Households are broken down into urban and rural. Rural is broken down into households with and without electricity. And then we have different end uses, lighting, cooking, etc. Here's some different cooking devices, for example. So that's just, this is kind of like a very simple example, but in most countries it will be a lot more complicated than that. But let me just show you, let me show you a few results. So this is a country which, think of it as being something like a developing country, but this one also has lots of crude oil production. So let's have a look at the energy balance and see if we can understand what's going on in the base year in this country. So let me look at it, say, for a base year of 2010. So this is an energy balance for Fredonia. You can see there's different fuels being consumed down here. We have, for example, the industrial sector consumes a lot of coal. There's a lot of electricity consumed in the household, industry and commercial sector. The transport sector mainly consumes oil products, so that's mainly gasoline and diesel. Here we have the conversion going on. So a negative number means something's being consumed, a positive number means it's being produced. So here's the crude oil being consumed in our oil refineries, being turned into oil products over here. Or similarly, if we look at electric generation, here's coal being used in an electric power plant, here's hydropower being used in an electric power plant, and then here's the electricity being produced. And then up here we have a summary of where do those fuels come from. So here you can see we're producing the coal in the country itself, and then the crude oil was actually, there's a huge surplus, right? We're producing huge amounts of crude oil. We're only consuming 180 of it, but we're producing 1,800. So it's a big oil exporter, this country. It's exporting huge amounts of oil. Okay. So those that picture can change over time. This is just a snapshot for 1 year. So in your scenarios, you'd explore how these numbers might change under different scenarios. So let's have a look at some of the results. Let's have a look at maybe total greenhouse gas emissions, seeing as we're here in a webinar about greenhouse gas mitigation. So here you can see some results for the total global warming potential. So here I've selected, I want to see the 100-year global warming potential. So this is taking the physical emissions of all the different gases, multiplying it by their global warming potential, and it's showing you the total GWP. So the GWP is basically a way of combining the methane and the carbon dioxide and the other pollutants together, so you can stack them all up together. And in LEAP, you can see that. Here we're looking at the results organized by sector. So we're looking at demand and transformation, so some emissions from demand, some from transformation, or we could organize this maybe by gas. So you can see here it's nearly all carbon dioxide. There's only very tiny amounts of warming from methane and nitrous oxide. So think of this as being, this is your scenario, right? This is a scenario for one particular scenario. This is like our baseline scenario. This one bar down here would basically be similar to your greenhouse gas inventory, but then we're making projections of it going forward. So the numbers grow as the population grows, as the GDP grows. In LEAP, you can actually compare different scenarios. So one of the ways you can do that is you can just plot the scenarios on screen. So here you can see here's our baseline or our reference scenario, and here's what we achieved in our mitigation scenario. We managed to reduce the emissions. Or you can compare them in all sorts of different ways. So here, for example, let's do it by sector again. And let's say now I want to look at the mitigation scenario, but I want to see what I've avoided versus my reference scenario. So let me actually show that for every year, maybe. I'll show it as an area chart. It's a bit easier to see. So here you can see the colored in lines are the results for my mitigation scenario, and the dotted white block at the top is what you avoided versus your baseline scenario. So LEAP has all sorts of tools for presenting the information all sorts of ways. You can get thousands of different charts out of it. That, of course, this is kind of very similar to, I mean, this is in keeping with the way that the IPCC and the UNFCCC talk about emissions. It's very much a territorial accounting for emissions. So we count up the emissions based on where the fuel is being combusted. So this is not accounting for any of the emissions from the oil being produced in the country and then exported. So the emissions from the exports will be counted under the accounts for the country that buys the oil. LEAP does have an alternative way of looking at things. So you can see here the emissions grow from 20 to 90 on a territorial basis. Another way of looking at it is to say, let's look at the extraction-based accounting. So this actually says what will be the ultimate emissions associated with any of the energy produced within the country. So this is not, you should not use this when you're doing your UNFCCC reporting. But you can see there you get a very different kind of result. It's much higher because there's this huge amount of crude oil produced in the country but not used in the country. So typically when you're doing UNFCCC reporting, you want to use this one, the direct at point of emissions accounting. And you can disaggregate that down a lot more. So for example, we might want to look at not just demand and transformation, but look at the sectors where it comes from. So if I do 2 levels here, you can see it's dividing down into the individual sectors. So you can see from here, it looks like the households are quite small, industry is quite small, and there's a lot of emissions coming from our electric generation. That actually can be a little bit misleading because in fact, the energy consumption in households is what causes you to have to produce the electricity down here. So there is one other view you can look at, which is you can say, let me take all my emissions and allocate them back to the energy consumption that caused that emission. So that's this other report here called direct plus indirect allocated to demands. And if we do that, then you can see the household sector, which is the household sector. It's let me just do 1 level down. There we go. Then you can see the household sector looks much bigger because this is saying there's emissions here within households, but that's also causing emissions down here under electric generation. So there's all sorts of ways of seeing your results. You can even say, what are my results? What are my results by sector and by fuel? You don't have to organize it so that years are on the x-axis. Let me put this down here. Let me put the fuels down here, for example. Or maybe put the fuels up here. Maybe that's more sensible. And then we do that as a bar chart again. So here you're looking at the different sectors and what are the emissions from the different fuels within those sectors. And you can even sort of animate that over time. I'm not sure if the screen will be fast enough to support this. But here you can see how the emissions are growing over time. You can see there's a lot of growth going on in the transport sector. Let me do that one more time. Okay, I just want to show you, that's just a sort of hint of the kind of results you can get out of LEAP. Let me just come back to this energy balance and show you, I just want to show you a couple more things and then I will stop. So I showed you this energy, the flows as an energy balance. Another kind of report you can get out of LEAP is to look at those flows as a diagram. So here's a Sankey diagram showing you the flows of energy through the country. So you can see, for example, there's a huge amount of crude oil produced that goes to exports. Or there's usually a lot of losses coming from things like electric generation. So this is a very easy way to sort of understand how the flows of energy are occurring in the system. Let me show you one other data set very quickly, because I mentioned the importance of showing you impacts. So I'm going to show you this experimental new model. So this is a little bit risky. I hope it doesn't crash on me. So this is a model that goes as far as looking at impacts. So this uses the IPC component of LEAP, and it calculates deaths and crop losses, premature deaths. So let's look at the results for that. Let me see if I've got a favorite one here. I think I've got it saved. So here, for example, we're looking at premature deaths from our scenario. So here's a baseline scenario. You can see that the deaths are going up a lot over time, from 250,000 to 600,000. This is for this particular data set is again fictitious, but it's a country that would be very similar to somewhere like Bangladesh with a population of about 150 million. So you see 250,000 deaths is very significant out of a population of 150 million. One of the nice things you can do in this calculation now is you can break things down. So this is the total deaths from small particulates and ozone. If we just concentrate on particulates, you can see you can look at the same results but in multiple different ways. So here, for example, we're disaggregating by gender, male and female, or if we go down a couple more levels, we can disaggregate by age. So here's different age groups. You can see the over 70s are particularly impacted. And you find out one of the policy dilemmas you have, or one of the policy challenges you have when dealing with air pollution, is that not only is your population growing, so there's more people around to breathe the same amount of population, the same amount of pollution, but also in many developing countries, the populations are rapidly aging. So by 2050, you will have a much older, on average, population, and they're going to be much more susceptible to the impacts of air pollution. So that's a big policy challenge. If we go down another few levels, here you can see the particular diseases that cause the premature deaths. So stroke is a big one, ischemic heart disease is another one. And then my favorite one, here's how much of the deaths came from indoor versus outdoor. And then my favorite one, although maybe I shouldn't say that because it's a rather depressing chart, is this sixth level, which is showing you sort of where the emissions came from. So here's the deaths caused by indoor air pollution. Here's the deaths caused by your own emissions in your own country. Some of the deaths are caused by natural background. So that might be like dust blowing in from a nearby desert. There's nothing you can do about that. And then this orange one is the deaths caused by pollution blowing in from a neighboring country. So in some countries, you only have control over this bar and this bar. But this gives you a very good idea of how your policies can impact on very, very important topics like premature mortality. So obviously that's not typically part of NDC reporting, but in terms of low emission development strategies and thinking about low carbon futures, it's really important to think about the potential co-benefits, because in many countries this issue is going to be much more at the forefront than thinking about CO2 emissions, but the two go together. So thinking about air pollution can help motivate action in many countries on climate action as well. So I've only shown you about 5% of what you can do with LEAP, but I hope I've given you at least a taste for the kinds of things you could do. And I think I should stop now because I've probably gone way over time already, and I'll hand it back to Marlon, and maybe we can have a few minutes for Q&A now, Marlon. So back to you, Marlon. Thank you very much.
So thank you, Charlie. Indeed, it was a very insightful presentation. And it's also nice to see the very significant and useful development to LEAP that's coming, and the expansion to water and adaptation, which is also very important to the UN Sustainable Development Goals and holistic planning at national level. So as you said, Charlie, conducting a mitigation assessment, especially at national level, requires consideration of many factors, and indeed is not an easy process. And as Sandra mentioned, LEAP provides a useful tool to make projections into the future and help us decide on mitigation options that can be undertaken. So I would like to thank everyone because I don't see any questions that has come in. So I'd like to thank everyone for their participation in this webinar. As you close this webinar, you will see a survey link. Please, can you complete that to help us improve the webinar experience? I apologize again for the technical issues we had with the webinar, and I wish everyone a happy weekend. So thank you to our presenters, thank you everyone, and happy weekend. Okay.
Thank you, Marlon. And maybe I could just say I can make the presentation available on the LEAP Facebook page as well, and I will send it to you also, Marlon, if you want to share it.
Yes, we will be making the presentation and the recording of this webinar available to all the registered participants. Thank you again, and thank you, Charlie. Bye, everyone.